Hello, good evening to all. I hope my voice is clear. So please let me know my voice is clear or not. Video is clear, I hope so. And just let me know my voice is clear or not. Yes, please. All thing is clear. So shall we start? Shall we start our today's topic, that is forging? Yes. All thing is clear now? Okay. Good. Very good. If all is clear, then I am going to start the forging process. And today the forging, generally the questions, okay, the questions from forgings are little bit lengthy. So in gate, less number of questions will be come in gate, right? Okay. So, okay, 5, it's a 5.01, 5 p.m. 1 minute is there, 5:51. Okay, so I will start today's session without any delay, because today I will take more than 1 hour 30 minutes. Now, forging is a process. What do you mean by forging, my dear? What do you mean by forging? Forging is a process where you will do a plastic deformation with the help of what? Die, or with the help of what? Anvil and hammer. As you can see, this is what? Heated workpiece, and this is what? Anvil. Anvil, where you place the workpiece and now you are hammering to the workpiece. Basically, you are applying a localized pressure. You are applying a localized pressure so that you should bend the workpiece into the desired shape. Am I clear? Because you bend the workpiece into the desired shape, okay, in a desired direction, got it? In a desired direction, you manage the flow of grain in a controlled direction. That's why the mechanical property of the forging process, the mechanical property of the forging products are what? Are very good. Because here you manage the flow of grain in the desired direction, okay? By applying the localized pressure, my dear, by applying the localized pressure, you manage the flow of grain. Am I clear or not? By applying the localized pressure, you are basically, what you are doing? You are applying the localized pressure. You are closely controlled, okay? By applying the localized pressure, localized load, we controlly manage the flow of grain, okay, flow of grain. So here you manage the flow of grain in the desired direction. That's why the mechanical property is what? Good. But what about the surface finish? The surface finish in forging is little bit poor. The dimensional accuracy in forging little bit poor. You know why? Here you can see this workpiece. Forging generally is what? Generally forging is what? Generally forging is hot forging. Okay, hot forging. Generally forging is what? Hot forging generally. So if you do heated the workpiece and if you apply the load, as you can see, the workpiece is heated. The workpiece is heated. So rapidly on the surface, what happened, my dear? Rapidly on the surface, oxide will be formed, right? Rapidly on the surface, what happened? Oxide will be formed. Oxide formation. Rapidly oxide formation. Now tell me one thing. Tell me your answer in yes or no. If the oxide layer will be formed. Why oxide will be formed? Workpiece is heated. You are doing forging in open atmosphere. So the oxide formation will be there. Yes or no? First of all tell me. Yes. Now if you apply the load, then the oxide layer will break. Oxide layer will break. If it break, then it will indent, it will press into the surface. Oxide layer will break when you apply the load with the hammer, okay, into the surface of the workpiece. Then the surface finish become what? Rough or not? Dimensional accuracy will not accurate now. So in forging, surface finish and dimension accuracy is very poor. But if you talk about the mechanical property in a forging is good. Why? Because by applying the localized pressure, okay, you can manage the flow of material in a desired direction. You can manage the flow of grain in the desired direction. That's why the mechanical property in forging is what? Superior. So the definition of forging is very clear. It is a process in which material is shaped by the application of localized compressive force, right? Localized compressive forces exerted either manually or either by external, with the help of hammer, with the help of some die, with the help of some hydraulic press machine, either, right? So this is, my dear, forging. Now forging are of two kind. Right? Forging are of two kind. The first kind of forging is what? The closed die forging. Here you can see a closed die forging. I hope, am I clear? The picture is crystal clear. The first one is the closed die forging. What we do in a closed die forging, my dear? You can see this is a bottom die, and this is what? This is the top die, right? This is the initial workpiece which we are going to place into the die, okay? Die has some internal cavities, okay? Now here die is in the open position. When you place the initial billet, this is my initial billet. This is what? Initial billet. Billet is what? Billet is the initial workpiece, right? When you place this billet and when you apply the load, okay, when you apply the load, then what happen? Die is going to close, right? Die is going to close. If the die is going to close, then what happen? The die is going to apply the pressure, right? So the material will flow into the cavity. Am I right or wrong? Material will flow into the cavity. See, once the die is going to close fully, like this, once the die is closed fully, here you can see the die is closed fully. That's why we say it is a closed die forging. Because the top die and the bottom die are going to meet each other when the die is going to be closed. Am I right? That's why we say it is a closed die forging. Okay, and the closed die forging will be complete, and the closed die forging will be completed only when the both die are going to meet each other. Here you people can see that the material can flow into the desired cavity. The material is flow into the desired cavity. Here the initial billet has taken the shape of the die. Am I right? Now you open the die and remove and eject the forged product. And what you do then? Then you do some cutting operation. Some excess material, you want to remove that excess material from this forge material, so that you will get the final component. My dear, the excess material which you removed from the forged component, okay, the excess material which you removed, the forged component is known as flash. Right now I am telling you, the flash is a very important, with flash is a very important, either it is an undesired part of the forging product, either it is an undesired part of the forging product, but without this excess metal, a forging can't be completed. Without this excess metal, a forging can't be completed. Am I clear? Am I clear? Am I clear? Later in the upcoming slide, after 4 to 5 slides, I will discuss about the flash. So don't worry about that. I will discuss about the flash. Okay. So you get the final component, but there is another type of forging. This is what? This is a open die forging. Here you can see there is a open die forging. In open die forging, you can see, this is a lower die, or you can say anvil, this is a hammer, or you can say upper die. If you place a workpiece in between the die, when the die is doing the hammering action, if the die is doing a hammering action, if the die is going to close to each other, they are not going to touch each other. Okay, they are not going to touch each other. That's why we call a open die forging, my dear. That's why we call a open die forging. Okay, so at the end of the open die forging, you will get your desired product. Look here, you will get the desired product. After doing the forging operation, you will get the desired product. After doing a forging operation, you will get the desired product. According to the shape of the product, we can select the shape of die, right? We can select the shape of the die. You can say we can select the shape of anvil, we can select the shape of hammer. According to the product, we can select the shape of anvil or shape of hammer. Am I clear? Let me know. Am I clear? Let me know. And those students who hasn't liked this session, please like this session. Okay. Yes, tell me, am I clear or not? Here, this slide is clear up to that. Okay, this slide is clear. I hope so. I hope so you understand what do you mean by open die forging and what do you mean by a closed die forging. Okay, so I am moving on the next slide. Now, as I am telling you, without flash, a forging will not be completed. How is it possible? So let me explain you how is it possible. I will explain this thing. Okay, suppose that there is a cavity. Let's say I'm in a closed die forging. I'm talking about the closed die forging here. I'm talking about a closed die forging. So please listen this concept very carefully. Okay, this is a upper die and this is what, my dear, this is the bottom die, right? This is a bottom die. Both the die are in the closed position. Please see, both the die are in a closed position. Right? This is a closed position of the die. Am I clear? This is a cavity. As you can see, this is what? This is the cavity. Here, if the volume of the inside cavity, okay, I will shade it also. This is upper die. Okay, this is upper die as it is visible, and it is what? It is a lower die. Am I clear? Now, inside the cavity volume, let's say this is what, my dear, this is the cavity. Inside the cavity volume, the volume of this cavity, let's say the volume of the cavity is 100 centimeter cube. This type of question will be asked in your interview, or maybe on the basis of this concept, a question will become into your GATE exam also. Okay, the volume of the cavity is what? Here, the volume of the cavity is 100 centimeter cube. Now, let me know that this is the billet. Okay, this is what? This is the billet. This is billet, which you have to place into what? Into the cavity. Okay, this is a billet, that is an initial workpiece. Now let me know the volume of the billet. What should be the volume of billet? Tell me, what should be the volume of billet? V stand for what? V stand for volume and B stand for billet. What should be the volume of the billet? Here the options are A, volume of the billet is equal to 100 centimeter cube. Okay, volume of the billet is equal to, or you can say less than 100 centimeter cube, and this is the option B. And option C, volume of the billet is greater than equal to 100 centimeter cube. So there are three options. Which option would you like to prefer? Which option would you like to prefer? My dear, if you take, let's say, before selecting any option, please try to understand the concept here. Please try to, yes, before selecting any option, please try to understand the concept here. Let me explain you what happened when you put a initial workpiece into the die. Right, this is the scenario. This is the die in open position. Right, this is a die in open position. Am I clear? This is a die, top die and bottom die in open position. Right, here you have placed the billet. Look, this is a billet. This is what? This is a billet. Right, this is what? This is billet. You can see this is billet. Okay, initial billet. You told me, sir, you have to take the billet volume 100 centimeter cube because the cavity volume is what? Sir, 100 centimeter cube. Now, let me explain you the thing. My dear, suppose when you apply the load, right now it is in the open position. Right now billet and die are not in contact. Now when the top die comes in a downward position, now see where the material is flowing. See, my dear student, where the material is flowing. Please see carefully. Please see carefully where the material is moving in the outward direction now. In the outward direction now, material will resist to flow inside the material. Initially material will not go inside the cavity. Why? Because the cavity of the die is very complex. Why? Because the cavity of the die is very complex. So it will require extra effort. Material have to face some resistance. So the easy flow of the material is outside the cavity. Initially material will flow what? In outside the cavity. Now what happen? If material will flow outside the cavity, look, here material comes. It is a nature of the material. Am I clear? Yes or no? This is the nature of the material. Okay. Once the material will flow outside, then after material will fill inside the cavity. This is the nature. My dear, if you take 100 centimeter cube, then what happen? Some of the material out of 100 centimeter cube, 10 centimeter cube material will go away from the cavity. Will the cavity fulfill? No. So you will not take this. Okay. Also, you will not take this. Right. So it is clear that the billet volume should be what? Greater than 100 centimeter cube. Am I right? Yes or no? Tell me yes or no. Arey Baba, tell me yes or no. So the billet volume should be greater than what? 100 centimeter cube. Now what happened? The initially billet is what? The initially billet, you know my dear student, it is a red hot. Okay, it is a red hot basically. Right, it is a red hot. Now you have taken the billet. Whose volume is what? Here the billet volume is greater than the volume of cavity. Right? The billet volume is greater than the volume of what? Volume of the cavity. Now, if you are closing the die, then what happened? The material get started. The billet volume get start to flow. The billet volume get start to flow in the outward direction because there is no restriction. Alright, there is no restriction. Also my dear, here remember one thing. This is the heated workpiece. Now my dear, the billet is moving in a outward direction. It is a heated it is a heated, it is a heated, it is a heated. Now, when it is flowing, initially it will flow very initially. Initially it will flow in outward direction very easily. Why? Because billet is heated. Once the billet, once the material get flow outside, then it comes in a contact, then it comes in a contact with the die, then what happen? It will be, my dear, cool down. It will be, my dear, cool down. See, here the material is going to be what? The material will going to be what? Cool down. See, the material will be what? Cool down. Is it visible? No, is it not visible? Here the material will be what? Cool down. See, here not. No, this is not the one. I will show with the help of white line. Okay, here the material will cool down. Here the billet is going to be what? Cool down. Right? If the material is get cooled down, it will not flow in further direction. It will not flow, my dear. It will not flow in further direction. It will not flow in further direction. Let me clear you one thing. It will not flow in further direction. Once the material gets cooled down, once the material gets cooled down, it will not flow further direction. It will stop there. It will stop there. Right? Now the twist will come here. Now the twist will come here. And what is the twist? Now the material which is flowing outside, 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 it is not able to flow outside further. Why? Because of this metal. Because of this metal, the material will not flow outside. Am I clear? Now, where the material will flow? Now, where the material will flow? Now, here, the material will start flowing. Now, if the material is not able to move in a forward direction because of this, then material will flow into the cavity. Then material will flow into the cavity. Then material will flow into the cavity. Am I clear, my dear student? So, the excess metal which flow outside, the excess metal which flow outside, right? And because of this excess metal, the billet material will start flowing into the cavity of the die because of this excess metal. Am I clear or not? Am I clear or not? Now, this will help to material. This will help to material so that it can flow into the cavity of die. That is the nature of flash. The excess material which you have taken, let's say the excess material which you have taken, here the billet volume, you have taken the volume of what? You have taken a volume, billet volume, let's say 110 centimeter cube. So here 100 plus 10 centimeter cube, na? Okay, 100 centimeter cube plus 10 centimeter cube. This is what, my dear? This is basically flash. So because of this excess 10 centimeter cube, the material get filled. The billet metal will start to fill into the die cavity. Am I clear or not? So in this figure, this is basically what? This is a 10 centimeter cube and this is what? This is 100 centimeter cube. This is the importance of flash. Without flash, the die will not fill. But after the forging, flash is not our desired product. Flash will not our desired product. After the forging, we cut the flash. Am I clear to you? Am I clear to you? Yes or no? Do you understand the concept of flash? Do you understand the concept of flash? Yeah, Pare Baba, tell me yes or no? Do you understand the concept of flash? Yes or no? Now, here, Chamankant did a one mistake. Chamankant did a one mistake. Okay, what is the mistake? I will tell you. What is the mistake? Chamankant did one mistake, right? By mistake, okay, by mistake, Chamankant did a one mistake, and what is the mistake? I will tell you the mistake also. Okay, I will tell you the mistake also. The mistake is, okay, cavity volume. Let me write down. The cavity volume is what? the cavity volume is what? 100 centimeter cube. The required, okay my dear, required billet volume, Chamankant has not taken, sir, but die is not completely closed. Die will be completely closed. There is a cavity. See, this is a cavity. You haven't seen properly. Mr. Asim Khan, see Asim Khan, open your eyes, okay, first of all wash your eyes with the water, lots of water or whatever you like, okay, whatever fluid you like, whatever liquid you like, wash your eyes with that liquid and see, there is a cavity basically, there will be a cavity, we provide a cavity in the die, right, we provide a cavity in the die, see here, this is basically, here the flash is there, right, here the flash is there, so we provide a cavity in the die for a flash, okay, for a flash. Now your eyes are open, Asim Khan, the concept is clear. So first of all, see, we provide a cavity in the die so that the die will be closed fully. But what the Chamankant did, it is required volume is what? Required volume of billet is what? That is 110, okay, 100 plus 10, okay, 100 plus 10. That is the 10 centimeter cube is the required flash. Okay. According to the calculation, the required flash is what? According to the calculation, the required flash is what? 10 centimeter cube, right? But what Chamankant did? Okay, Chamankant ki spelling kya hai? What the spelling of Chamankant? Chaman, where is Chaman? Yes, Chaman is there. Now, Chaman, what did Chaman? Chaman take the billet volume, okay, by mistake take the billet volume, how much? He has taken 120 centimeter cube. Now, Asim Khan, here the problem will become. In the die, the cavity of flash, Asim Khan, here the problem will become. The cavity of the flash, in the die, the cavity volume of the flash is 10 centimeter cube. But Chamankant has taken 10 centimeter cube extra, means what? 100 plus 10. This is a required flash. By mistake, Chamankant has taken the extra volume. That is what? 10 extra. This is extra. Okay. This is what? This is the extra one. The Chamankant which has taken. Am I clear? Now the problem will become here. Now here the die is not going to be closed fully. Now here Asim Khan, the die will not going to be closed fully, because for a flash you provided, according to the cavity of the die, according to the cavity volume of the flash in a die, okay, you provided 10 centimeter cube extra in the billet. But here Chamankant has taken extra, another 10 centimeter cube extra. Will the die is going to close completely? Will the die is going to close completely? No here. Now, what should we do? For that purpose, suppose if you have taken some extra material, okay, I have taken so much, let's say I will going to rectify, I will taken, the extra material is so much. If I will take 110 centimeter cube, let's say, because it is a calculation mistake, by calculation you will take little bit more, let's say 5. Now, the die is not going to be closed fully. Then what we do? For that purpose, we provide a gutter. Have you heard the name of gutter in your journal life? Have you heard the name of gutter in your journal life? Tell me yes or no. All of you, I need a contribution from all of you. Have you heard the name of gutter in your journal life? Gutter in your journal life. In gutter, what we throw? Whatever be the excess thing, we throw in a gutter. So my dear student, in forging, we provide, let's say, please see here carefully. This is a cavity here. Okay, this is what? This is the cavity, let's say this is a cavity. If you have taken the extra material, okay, this is what? This is the flash, see, this is a flash. If you have taken the extra material required, then the required, if you have taken the extra material, then the required material, then we provide another cavity. We provide another cavity which is just after the flash, and it is called gutter, So if you have taken by mistake the extra material, then applied the load so that the excess metal will go in the gutter, from flash it will go into the gutter, so that Asim Khan, the die will close completely. Here the die will close completely. Am I clear? Those who haven't liked the session, please like the session. Okay, first of all. Now, am I clear to all of you? So the die can completely, fully. Am I clear? Now, here, one graph which is a very important, it is a very, very important graph. Okay. That graph is basically in between. Beta. Why? That is a forging load versus forging stroke. So let me again here make the axis. This is what? This is basically the forging load versus forging stroke, right? Suppose that at that point, my dear, at that point, okay, this point, when the both die comes in a contact with the workpiece, okay, at that point when both die comes in a contact with the workpiece, then what happen? The load increases. Okay, listen me here carefully. When both the die comes in contact to each other, then what happen? The load increases. See, the load increases. Now, my dear, here the twist will become. At that point, flash starts begun. At that point, let's say here, this point, at that point, see, here the flash starts begun. Little bit the flash has started. The excess material comes here. Okay, if the excess material comes here, tell me, if the excess material comes in between the die, so the required load increases or not? Because it is an excess material. Because of that, die has to apply more load so that it can overcome the flash. So my dear, please see this graph. Here, because flash begins to form, here flash start forming, so the required load increases again, and the maximum value of load you will get at the end of forging. Always remember, at the end of forging, you will get the maximum value of load, right? So, at the end of forging, you will get the maximum value of load. Always remember. Am I clear? This is a very important thing in forging. If someone is going to be asked, let's say someone is going to be asked, in forging, where you get the maximum value of load? So, your answer should be at the end of forging. At the end of forging, the load will be what? The load will be maximum. Am I clear or not? Tell me. Am I clear or not? Hello guys, tell me. Am I clear or not? So at the end of forging, the load value is what? Is maximum. Clear? This is a very, very important thing, right? Now, there is one question which will become steps of forging. Okay, now there is one question will become, that is what? That is the steps of forging. Let me give an answer. Okay, I am going to ask a question. Suppose that I have to make a product. Okay, this type of product. Okay, I am going to make this type of what? This type of product, right? I am going to make this type of product. right? I am going to make this type of product, right? I am going to make, I want to make this type of product, my dear. Am I clear? I want to make this type of product. From which? From the initial billet. This is my initial billet, right? This is my initial billet. This is what? This is my initial billet. This question will become several times. This question will become several times in other exam like ESC, like ISRO, DRDO, okay, in other exam. So it may be a chance that a theoretical question will be asked in your GATE exam also. That's why I am teaching, otherwise I will not teach. Also it is in your course, or that's why I am teaching, right? So this type of product you want to produce. So it is obvious you want to produce this type of workpiece from forging by using this billet. So there will be this type of cavity. Am I clear or not? There will be this type of cavity where you place the billet, okay, and you will get the product. Now tell me one thing. If this type of die is there, can you place the billet directly into the die? Suppose that you want to produce that type of shape, and this is the shape of die. Right? This is a cavity of die. Can you place the billet directly into the die, or you will give some journal shape? Can you place the billet directly into the die, or you give the journal shape? Tell me yes or no. It is a very, 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 very important thing. These questions will become in your ESC, okay, ISRO, DRDO, BARC, and there may be a chance a question will be come into your GATE also. Not possible now? Not possible. Yes, very good. No beta Rajat Jain, apart from heating, other thing is also required. Okay Rajat, apart from heating, also other things are also required. Now what are the other things? My dear, you have to give some journal shape to the billet, which is nearby to this shape. You have to give some journal shape to the billet which is nearby to this die shape. And what are the steps? This is very, very important. Okay, these steps was asked in ESC. Okay, these were asked, I tell you, ESC exam, DRDO, ISRO, BARC. Okay, these steps was asked in this exam. So there may be a chance a question may be coming in your GATE exam also. So these are some steps by which we can apply on the initial billet. Then after you have to put that billet into the cavity. What are the steps? Listen me carefully. Now the first step you write down also. First of all you write down, then after I will explain. I am going to give you have to write down only these steps. Okay, because it is very necessary that when I am explaining, it should be in front of your eyes. So I am giving you 1 minute. So please write down these steps. Okay, please write down this step. I am giving you only what? 1 minute. Your time starts now. I am giving you only 1 minute. Yes, please. Copy. Very, very important steps. Please copy. Because when I am explaining, it is necessary that it should be in front of your eyes. Otherwise, you are not able to understand. If it is not in front of your eyes, then you will not able to understand the steps in forgings. Okay. Have you completed? 43 minutes, 44 minutes, 45 minutes, 46 minutes, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59 and 60. Time is up. I hope you have completed. Now I am going to explain the steps. What are the steps? My dear, the first step is what? That is fullering or swagging. This is the initial stock, as you can see. This is what? You can see this is my initial stock, right? Now, first step is what? Either you can say fullering or either you can say swagging. Both the meaning, the function of both the thing is same. Now, what we do? What we do in a fullering and swagging. Now, we are going to apply the load, my dear. We are going to apply in fullering and swagging. What we do? In fullering and swagging, what we do? We are going to apply a load on a workpiece, right? We are going to apply a load on billet so that we can reduce its cross section. We can reduce its cross section and increase its length. We can reduce its cross section and increase its length. This is my first step. Am I clear? Am I clear? In fullering and swagging, we apply the load on the stock so that we can reduce its cross section and increase its length. This is the first step. Clear? Hurry up. You have to reply me after every step. Otherwise, it will take a lot of time. You have to reply me after every step. Fullering and swagging is clear? Fullering or swagging is clear? You have to reply me after every step. What we do fullering? What we do in fullering or swagging? You have to apply a load with the help of die so that cross section area decreases and length is increases. Right? This is the first. Now the second step. See, before explaining the second step, please see the product or please see the cavity. Please see the product or you can say a cavity. Look, here the required material is more. See, at the back side, here required material is more. Yes or no? At the back side, required material is more. Yes or no? At the back side, required material is more compared to the front side. Required material is more compared to the front side. So what we do? Next step, we have to apply the next step. What is the next step? The next step is edging or rolling. What is edging or rolling? In edging or rolling, we gather, in edging or rolling, we gather the excess material where it required in the final product. In edging or rolling, we gather the excess material, where it required. See here, my dear, we do second step, that is edging or rolling. This is what? Edging or rolling. Here we gather the excess material. We gather the excess material where it required in the final product. Am I clear? Am I clear? Tell me yes or no. Then after I will move on the next step. In edging or rolling, we gather the excess material where it required in the final product. Am I clear? Am I clear? Tell me yes or no. Am I clear? Tell me, Baba, am I clear? Now, so you have gathered the excess material where it required in final product. Now, what we do then? Now what we do? See, here, this is a longitudinal axis. Okay, this is you can see a longitudinal axis, or I can say this is a longitudinal axis, right? This is a longitudinal axis. Now see the final product. See in a final product. Here the longitudinal axis, here the axis is going to be what? Bend. The axis is going to be what? Bend. Yes or no? The axis is going to be what? Bend. Yes or no? Yes, na. So after edging or rolling, we do bending. In bending, we bend the longitudinal axis from one or two. We bend the longitudinal axis from one or two location. In bending, what we do? We bend the longitudinal axis at one or two location so that it can fit into the die. Am I clear? Up to bending, there is any doubt? Up to bending, if there is any doubt, tell me Baba, up to bending there is any doubt? I am putting lot of effort, okay, so at least write down in the comment, yes or no. Up to bending there is any doubt? No doubt now, no doubt now. So up to bending you have no doubt. Now, suppose you did lot of thing. Suppose you did lot of thing. You did what? Bending. Now, okay, you did what? You did a bending. Okay, you did what? You did bending. So, fullering is clear, fullering or swagging is clear. Step number 2, edging, rolling clear. Step number 3, bending is clear. Now, you people, what you found? What you found? You found that this cross section, I mean a particular section of the product, is little bit thick. Okay, a particular section of the product is little bit thick and it is not able to fit into the die, and it is not able to fit into the die. Okay, this section, let's say, my dear, let's say this section is little bit thick and it is not able to fit into the die. So what do you do? Tell me, what do you do? You want to fit this product into the die so that the die will be closed completely. So you reduce the cross section. If the thickness is large, then you reduce what? Reduce the thickness of the product so that it can fit into the die. It can fit into the die. Right or wrong? Tell me, are you getting? Are you getting? So, after bending, we do fourth step, that is drawing or cogging. That is drawing or cogging. In drawing and cogging, we reduce the thickness of the product. Am I clear? In drawing or cogging, we reduce thickness of a product. Clear? Tell me. Drawing or cogging, we reduce thickness of a product. Am I clear or not? Am I clear or not? Arey Baba, tell me, am I clear or not? In drawing and cogging, we reduce thickness of what? We reduce thickness of the product so that it can fit into the die. Right? 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 Now, from the above process, there may be a chance. From the above process, there may be a chance. Here you can see the longitudinal axis is parallel to the plane. The longitudinal axis, this is a longitudinal axis. Up to that, maybe there is a chance that it is parallel to plane, right? It is parallel to what? It is parallel to horizontal plane. But during this process, if the longitudinal axis is bent, in such a manner, now the axis is not parallel to the surface, the axis is not parallel to the die, the axis is not parallel to the horizontal, will it settle down in the die? Will it be settled down in the die? Tell me yes or no. Will it settle down in the die? Will it this settle down in the die? Tell me yes or no. No, na, it will not settle down into the die. So what we have to do, dear? What we have to do? We have to settle down into this, into the die. So for that we have to flat the longitudinal axis. We have to flat the longitudinal axis. So that process is known as what? Flattening. That process is known as what? Flattening. Where the longitudinal axis now perfectly parallel to the what? Plane, horizontal plane. So it will be settled down into the die. Am I clear or not? Am I clear or not? Tell me yes or no. Tell me yes or no. So the next step is what? Flattening. This is a step number 5. So the next step is what? Flattening. Tell me yes or no. Is it clear? Is it clear? Arey Baba, tell me yes or no. Now it's a 5:50. Okay, we have covered only 2 concepts, and today I am supposed to cover a lot of things. Okay, I am supposed to cover a lot of things. So I think tomorrow I have to again take the forging. Tomorrow I have to again take the forging. Apart from forging, I will take one more extra topic. Right? Okay, clear now? Clear now? So next one is flattening. Right? Next one is flattening. I will show you. This is a flattening basically. Look, this is what? This is a cogging, drawing and cogging. Remember, this is what? Drawing and cogging. This is what? Drawing and cogging, my dear. Okay, drawing and cogging. What we do in drawing and cogging? What we do in drawing and cogging? We reduce the thickness of the bar so that it will be settled down into the die, right? After drawing and cogging, if the longitudinal axis is not parallel to the horizontal plane, then we do a flattening. See, with the help of hammer and anvil, I am going to settle down. I am going to make the longitudinal axis parallel to the plane. So it will be settled down into the die. So see, the operation is used to flatten the stock so that it will fit properly into the die, so that you can close the die very nicely. Am I clear? Am I clear? Am I clear? So are these steps are clear? Are these 5 steps are clear? Tell me yes or no. Are these 5 steps are clear? Tell me yes or no. Are these 5 steps are clear? Okay, now the 5 steps are clear. Now the next step is the 6th one, that is blocking. That is blocking. Blocking means what? You are blocking something. You are blocking something. Okay, Chamankant is running away like that. If Chamankant is running away, here Pintu Adak is standing. Okay, here Sukumar Maji is standing there. Here I am standing here. So we 3 people are blocking the Chamankant. We 3 people are blocking the Chamankant. We are not tightly hold the Chamankant. We are just blocking the Chamankant. Okay. Okay, are you getting my point? Are you getting my point? Suppose we have to block the Chamankant. We don't have to grip the Chamankant. We don't have to, tightly grip the Chamankant. We have to block the Chamankant. So here I am standing, here the Chamankant. And in front of Chamankant, let's say Ashu is standing, and there Pintu is standing. So we 3 people are going to block the Chamankant. So Chamankant will not move, okay, so much here and there. So that operation is blocking. So basically, my dear, what we do, whatever you get the product after flattening, whatever the product you get after flattening, you are going to place that product into the die. That product into the die. See, you are going to, whatever product you are getting after flattening, whatever product you are getting after flattening, you are just going to place into the die. See, you are just going to place into the die. Now, I have placed the product, right? This is, let's say, my product. I have placed the product into the die, right? Now I am closing the die. I am closing the die. Is the die is fully closed? Tell me. Is the die is fully closed? Tell me yes or no. Is the die is fully closed? Are tell me, Baba, yes or no. Is the die is fully closed? Is the die is fully closed? Is the die no, na? So this is a blocking operation. In blocking, we want to know. In blocking, we want to know whether the product is properly fit into the die or not. In blocking, we are going to close the die partially, right? In blocking, see, in blocking, we are going to close the die partially. We are going to close the die partially, not fully. Basically, I want to know whether this product, this workpiece is easily fit into the die or not. If I am satisfied, okay, it is perfectly fit into the die, then what I will do? I am going to close the die completely. Fully close. Fully closed. Now, this is a fully closed. That is, this operation is called as finishing. This operation is called as what? Finishing. This is what? This is blocking. This is what? This is finishing. This is blocking. This is finishing. Right? This is finishing. So, my dear, after blocking, if you satisfy that the product is fully settled down into the die, then you have to close the die fully. That is known as finishing operation. Am I clear? That is known as finishing operation. Yes or no? Yes or no? Is it clear? Is it clear? So after finishing, you will bring the product, you will bring the forged product. After finishing, you will eject the forged product from the die. After finishing, you will bring the forged product from the die. Then what you do? there will be a excess metal in the form of flesh, there will be excess metal in the form of flesh, then you have to cut or trim, you have to cut or trim that excess metal which is present in the form of flesh into the forged product. Am I clear? So the last step is cut off or trimming, trimming or cut off. So see all the step at a one place. So after blocking, blocking means partially close the die, then you apply finishing operation. Die are closed fully, so the exit impression will be come onto the workpiece. Then you eject the forged product, forged material from the die, and you are going to remove the excess material in the form of flesh by applying the step trimming or cut off. Am I clear? Are those steps are clear? Are those steps are clear? Tell me yes or no. Are those steps are clear? Are those steps are clear? Are those steps are clear? Yes or no? In the exam it will become, he will be asked, okay, the arrangement of the forging step, these are what? These are the steps involved in what? Hammer forging or operation involved in forging. So this is a very important, my dear, this is a very important, got it? This is a very important. If maybe you have seen some question is ESC, BARC, DRDO, where you find this type of question, and there will be a chance that the question will become in your GATE exam also, right? So here I have completed this one. Now I am moving some basic formula which will be used in forging. Okay, today I am not able to complete the forging analysis, but I will try myself if the time permits. If the time permits, then I will going to complete the forging analysis also, right? Today I was planning to complete the forging fully, but I don't think so that I will complete the forging fully. Okay, so tomorrow I will complete the forging. Let's see up to 6:30 how much we are going to cover, right? So these are some basic formula, and I hope you are familiar with that. Now it is a engineering strain. What is that? Change in length divided by initial length. You know that. Okay, because already in the strength of material you know that. Okay, what are the engineering stress? That is a load divided by initial area, right? True stress, that is load divided by instantaneous area. If you multiply and divide by initial area, then P by A naught comes stress and A naught by A comes here. So true stress equal to sigma into A naught by A. So I hope you familiar about this formula. You are familiar with this formula. Okay, and you can also write that the true stress is also equal to stress into 1 plus E. Okay, that is a engineering strain and engineering stress. Am I clear? Are you aware this formula? Are you aware to this formula? These two formula, this formula. Okay, are you aware to this formula? Are you aware to this formula? This, okay, this and this. Is that clear? I mean, these are the basic formula you have seen in the strength of material. I have just revised it. Okay, I have just revised it. And there is a one more formula for true strain. There is a one more formula for a true strain. True strain equal to what? ln of A naught by A, or you can see twice of ln D naught by D. Also you know A naught L naught equal to instantaneous area, instantaneous length. So A naught by A equal to L by L naught. So instead of A naught by A, you can write L by L naught. Okay, am I clear? These are some basic formula, and I hope so you are aware that. Are you aware that? Are you aware? Shall we move to the next slide? Shall we move to the next slide? Yes or no? Tell me please. Shall we move to the next slide? Tell me yes or no. Okay. Now, a question is there. Now tell me the answer please. A question is there. Now tell me the answer please. A question is there. Now tell me the answer. GATE 2007. GATE 2007. A question is there. Now tell me the answer please. Those students who are seeing this session, if you like this session, then please like this session. Okay. Like this session. If you are like this session, Yes. In a open die forging, a disc of diameter 200 mm and height is what 60 mm compressed without any barreling effect. The final diameter of the disc is 400 mm. The true strain is simple na? True strain. True strain is what? True strain is what? ln of A naught by A, you have seen, or twice of ln D naught by D. Right. So, twice of ln disc of diameter 200, okay, 200 divide by the disc of die 400. Now, here the answer is coming, I think the answer is coming negative 1.386. Am I wrong or clear? Am I wrong or right? Am I wrong or right? Here the answer is coming minus 1.386. Yes or no? Here the answer is coming minus na? Minus sign is coming na? Minus sign is coming na? Yes or no? Negative na? But there is no negative sign in the option. Arey Baba, don't worry. The answer is what? It should be 1.386. You use this formula for the tension. You use this formula for the tension. For the tension it will be a positive. For a compression it will give the negative value. Okay, sir, please take class extrusion analysis and wire drawing analysis completely for IES exam. Srinivas Pillai, here unfortunately we are dealing the gate crash course, my dear, but still I will try myself. Still I will try so that I will take a complete. Okay, okay, Srinivas Pillai. Okay, Srinivas Pillai, but actually here we are dealing the gate crash course, na? So how can I take the ESC? But still I will try. Tomorrow I will start the extrusion. Okay, Srinivas Pillai. Tomorrow I will start the extrusion. So I will try to cover all the things, but still we are dealing what? We are dealing the gate crash course. Okay, got it? So whatever you have a doubt, you can ask in that session. Okay, I will give you the full notes. I will, in that session I will cover at least for the gate. If the time permits, then I will cover what? For ESC also, right? For ESC also. If I'm not able to cover the ESC also, okay, so if some topics are left, then I provide the notes. Then I will provide the notes. Okay. Now, solve this question. Very easy questions are there. Very easy questions. Solve this question. Today, Srinivas Pillai, don't miss the session, because today I am going to cover in forging analysis. Maybe today I am going to cover forging analysis which comes in ESC. Srinivas Pillai, if you are there, today I am going to start a forging analysis which comes in your ESC also. Got it? It's a very, very important. And nobody in the India is going to teach forging analysis for gate point of view. So don't miss that if you are there. Right? Now tell me the answer. Now tell me the answer. Yes, please. Tell me the answer. Maybe today or tomorrow I will start the forging analysis. Okay, if the time permits. Yes, option C. You have to again find the true strain. Very simple questions are there. Yeah, very simple. Yes, option C. Right? Option C. Now, tell me the answer. Tell me the answer. सर आज रिजल्ट आया है, प्लीज थोड़ा जल्दी. आज रिजल्ट किसका रिजल्ट आया चमनकांत? आज रिजल्ट आया है, प्लीज थोड़ा जल्दी किए लीजिए सर. मतलब आज जल्दी छोड़ दूं ऐसा क्या चमनकांत? डू यू वांट टू लीव अर्ली? टेल मी, डू यू वांट टू लीव अर्ली? ओके, सो आई एम नॉट गोइंग टू डिस्कस forging analysis today. If you want to leave early, then tomorrow I will start. Tomorrow I will start the forging analysis. Don't worry about that. Okay, tomorrow I will start the forging analysis. Okay, okay. So this is the last question. This is the last question. Don't worry. This is the last question of today's session. Tomorrow I will start the forging analysis. Got it? No sir, please continue. Because forging analysis we are not going to able to complete today also, but still we can try. Okay, Chaman, you will see the recorded session na. It will always be there in the playlist. Otherwise we are not able to complete na. Yes, the answer is D. The answer is D. A solid cylinder of diameter 100 mm, okay, diameter 100 mm, height is what? 50 mm, is forged between two frictionless flat die at a height of what? 25 mm, at a height of 25 mm, the percentage change in diameter. My dear, first of all you have to find the initial volume pi by 4 d naught square into h naught equal to pi by 4 d final square into h final. Okay, this will be cancelled. So d final will be comes out 141.4 mm. Yes or no? Because d naught is what? D naught is 100, h naught is 50, and h final is what? H final is 25. Right? So d final is 141.4. So the percentage change, that is delta d divided by what? D naught into what? 100. So d final minus what? D naught divided by D naught into 100. So d final is 141.4 minus 100 divided by 100 into 100. So it will become 41.4%. Right? That is answer option D. No one will teach forging analysis in a proper, so please continue. Yes, are you able this thing? Are you able this thing? Are you understand? Are you understand, people? Tell me. Are you understand? Are you getting this thing? Yes or no? Are you getting this thing? Yes, please tell me. Okay, because forging analysis I am going to divide in two parts. One is open die analysis for slab and open die analysis for cylindrical workpiece. So today I will teach, sir, have you taught a casting defects, types of casting in any other video other than the crash course? Actually, Rishabh, generally the defects are generally not comes in your gate exam, but if the time permits, I will also teach the casting defect. Don't worry, I will take a extra class, I will take a session, another session where I will cover those types, because here I am focusing, here my focus is on what? Here my focus is on the types of numerical which will be comes into your GATE exam. Rishabh Kumar, are you getting my point? Here my focus is on what? The type of question which will be comes in your GATE exam, and generally you know in GATE exam the numerical questions will become. Are you getting my point? Yes or no? Are you getting my point? Yes or no? It's up to you. It's up to you whether you want to solve the numerical in your GATE exam or not. I have covered the almost all type of numericals in the casting, in welding, in machining. Okay, so for a GATE point of view there will be a different strategy. Right, for a GATE point of view there will be a different strategy. Here we are dealing a crash. If you want to learn a detail, then we have launched a program, then we have launched a smart class program now. Here we will take 4 hour daily 4 hour classes, and here we will cover all the things, even theory also, even numerical also, even along with numerical a theory portion will be covered in the smart classes. But here we are dealing what? A crash course. At least in your minimum time you will get the maximum output. At least in your minimum input you will solve the maximum numerical. That is the point of the crash course. Right, Rishabh Kumar? Okay. So now this is a forging analysis, my dear. Forging analysis are of two types. Right? Forging analysis, in our course we have to do a forging analysis. We don't have to do a derivation. We have to understand a relation or a formula in a better way. We have to understand a relation or a formula in a better way. So those who are in the live, please be attentive for a coming 30 minutes. Be attentive for a coming 30 minutes, because these are very important. Okay, forging analysis is very important. Now, analysis of forging. Right, my dear? Analysis of forging. Now, analysis of forging, in our course, we have to do a open die forging. First of all, open die forging. First of all, open die forging. Right? And the question is, why I do a analysis? Why I do analysis? Because before forging, the analysis is very important. Because with the help of analysis, we able to know with the help of analysis, we able to know, right? We able to know how much force will become. Okay, with the help of analysis, we know, okay, how much load, okay, load is required. How much load is required, okay, for forging, okay, before the action, Before the process. Before the process. Am I clear or not? Before the process, we able to know that how much, before the process, we able to know how much load will be required for the process. And according to that load, my dear, and according to that load, okay, according to that load, try to understand here, okay, try to understand here, according to that load, you will design a die. Suppose that if the load for the required forging is 100 kilonewton and you haven't prepared a die, you prepare a die which can sustain only 90 kilonewton, then the die will fail. But before process, if you know that 100 kilonewton force will be come for the forging, then you then you design a die which can sustain 100 kilonewton or more than 100 kilonewton force. Am I clear? Am I clear? Am I clear? Yes or no? Tell me your answer. Am I clear? Yes or no? Am I clear? Yes or no? Please. So, analysis is required before forging, before the actual process, so that you can know how much actual force will become during the operation. During the operation, right? During the operation, so that you can prepare a die, right? You can prepare a die. Now, open die forging, we have to do an analysis, my dear. We have to do an analysis for two cases. First case I will discuss today. Second case, that is the cylinder, I will discuss tomorrow. The first case is slab analysis. Slab analysis. Slab analysis. Right, and the second one is cylinder analysis. Cylinder analysis. And I think in the last 2 years, a question will become on a slab analysis. A question came on a slab analysis. In PI question came in 2008 or 2010 in cylindrical analysis, in PI exam. In mechanical, a question came in slab analysis in the last 2 years. So it is important, right? It is important. Now, you don't have to do the derivation. You don't have to do a derivation, first of all. You have to understand the relation in a very well manner. Got it? In very well manner. Now, try to understand. Before that, you have to understand some assumptions. You have to understand some assumption for the open die forging. I think today we are not able to complete. Mr. Pillai, are you there? If Mr. Pillai, are you there? Then today we are not able to complete the open die forging. Okay, I mean the open die forging analysis, because first of all I have to explain the assumption. Then it will take more than 1 hour. So if in today within a 20 minutes I will complete the assumption. Okay, and just after the assumption, the slab analysis is compulsory. If there will be a break, if the topic is discontinued, then there is a no meaning. Then there is what? There is no meaning, Mr. Pillai. Because up to 6:30 I am able to cover only the assumption, because the assumptions are very important. Very, very important. You know how these assumptions was asked? These assumptions were asked in the ESC exam. See, in the ESC exam, these assumptions were asked. So I can't slip these assumption. Okay, I can't slip this assumption. So what I do, I will continue the analysis forging tomorrow class, because it will take, because if I teach you the assumptions right now, just after the assumption, slab analysis is very compulsory, right? Slab analysis is very compulsory. Got it? Got it? So tomorrow again I have to teach the assumption, then after I will start the slab analysis. So again the time is going to be waste. So in tomorrow class I will continue the analysis of forging. Okay, so today I am going to end this session here. So tomorrow we will meet here at 5 p.m. Got it, Mr. Srinivas Pillai? Got it? So today we are going to end this session here only. Tomorrow we will continue with the forging from the analysis, and once I complete the analysis, sir, that's why I am saying I am in second year learning first time. So tomorrow I will do the forging analysis also, plus I will start the extrusion also. Srinivas Pillai. Okay, Mr. Srinivas Pillai, tomorrow I will complete the forging analysis and I will start the extrusion also. Okay, so we will meet in tomorrow class. Sir, one more request. Yes, please tell me. Mr. Srinivas Pillai, what's your demand? What's your demand? Mr. Srinivas Pillai, you can connect to me on my Telegram group now. You know, you can connect to me on my Telegram group. Here, there you can do the discussion. There is no problem. Whatever your demand, I will fulfill. But it is compulsory that demand should be restricted up to only study. Okay. So, in CNC, please take transformation. I have completed CNC now or not? I haven't completed CNC. Transformation you have to use, okay. Sure. Sure. Not an issue. A simple matrix. Okay. Okay. So we will meet tomorrow. Got it? Thank you very much. Yeah, I will upload the notes also. I will upload the notes also. First of all, let me remove some things. Assumption. Now I am going to save PDF, my drive, crash course, metal forming, lecture 2. Okay, thank you very much. We will meet tomorrow. My Telegram group, you can search my Telegram group. You can search my Telegram group. My Telegram group is what? You can search my Telegram group by the name. Simply write down Aditya Pal Gate Academy. Right? Gate Academy. Simply write down Aditya Pal Gate Academy. Right? You will get my Telegram group, Mr. Pillai. Or simply if you write Aditya Pal, then you will get my personal Telegram. Okay? Thank you.